Now that we have talked about parallelograms and special types of parallelograms, we're going to look carefully at kites and trapezoids. So we've talked about this branch, but now we are going to focus on the kite as well as the trapezoids. Notice that these are distinct shapes from one another. So a kite has properties that are specific to it, and then the trapezoid has properties that are specific to it, but an isosceles trapezoid is a type of trapezoid. So a kite has one pair of opposite angles that are congruent. And remember, if we have things that are congruent, that means that we set them equal. A kite's diagonals are perpendicular. This means that they're 90 degrees. This is the exact same property we had for a rhombus, but a rhombus has other things that are true that a kite does not have that are true, which is why these two are not connected on our flowchart. And a kite has two pairs of consecutive congruent sides. The word consecutive means next to. So these two sides are congruent, and these two sides are congruent. Just for reference, your opposite angles that are congruent are in between the two sides that are not congruent. And then just as we've done, if it's congruent, A equals B. The trapezoid and the isosceles trapezoid are very similar. The trapezoid has only one pair of parallel sides. And we've talked about how if the only thing we know is that something is parallel, that we do not have enough information in order to be able to solve for something. So a trapezoid we're not going to see when it comes to solving problems, but we will see when it comes to recognizing the properties. An isosceles trapezoid, however, we will be able to use in order to solve for some missing information. So we have three things that are true. We have that the diagonals are congruent, we have congruent legs, and we have congruent base angles. So we're going to take a deeper dive into the isosceles trapezoid to see what that will look like. So an isosceles trapezoid has congruent base angles. The base angles can be on the long side or they can be on the short side, but either way, these pictures are the same. The trapezoid is just rotated or flipped. So base angles don't just mean what's on the bottom. Base angles mean the pairs of obtuse angles and the pair of acute angles. But they're not all congruent to all four. That would mean that we were dealing with four right angles. The two that share the short side are congruent, and the two that share the long side are congruent. We also know that the diagonals are congruent. So what that means is that this diagonal right here is congruent to this diagonal right here. We do not know that the two halves of the diagonals are congruent, but we do know that diagonal AC is congruent to diagonal BD. And we know that the legs are congruent. The legs of a trapezoid are these parts here. They are the ones that connect the base angles that are not congruent. So the legs are what make the diagonals on the trapezoid. They are not going to be the base, right? We have the base angles at the bottom or the top. The diagonals are those, or the legs are those that are slanted at an angle. So let's go ahead and practice figuring out which properties we're looking at for our kite, trapezoid, and isosceles trapezoid. And I have all of the properties listed here, but know that it is going to be one of these three shapes. So I know that the angles are, well, I see that I have two next to each other and two next to each other. So this is that my base angles are congruent. I know that the diagonals, I don't know anything because I don't see any diagonals drawn. And finally, I know that the legs are congruent. Okay, and I know those are the legs because they are in between the base angles that are not congruent. And that is the isosceles trapezoid that we were just talking about. This one, I see that I have what we call consecutive sides as being congruent. Those are ones that are next to each other. So here for my sides, I can say that the consecutive sides are congruent. I don't know anything about the diagonals. I see nothing drawn. And then these angles here are opposite angles are congruent. And so if I have specifically the consecutive sides being congruent, that right there should be an alert that it's a kite. That is the only thing that is true. However, for our angles, we should actually be more specific. It's not that all opposite angles are congruent, but there is one pair of opposite angles congruent. If we had two pairs, that's when we start getting into our parallelograms. But if only one pair and consecutive sides being congruent, that tells us we have a kite. With this one, I don't know anything about the angles. I don't know anything about the diagonals. I do know that there is one pair of parallel sides. And if that's the only thing I know, then I know that I have a regular trapezoid. So always, sometimes, never. So let's remember that we have a quadrilateral, and there are three kinds of quadrilaterals we talk about. We talk about parallelograms, we talk about a kite, we talk about a trapezoid. Specifically today, we are just looking at the kite, the trapezoid, and the isosceles trapezoid. So we're going to focus on those three. So an isosceles trapezoid is a type of trapezoid. That is always the case. You cannot have an isosceles trapezoid unless it has that property of a trapezoid that says opposite sides are parallel. A square is a type of trapezoid. That is never true. There is no way that I can have a square, which exists all the way over here in parallelogram land, with the trapezoid. So that will never be the case. Quadrilaterals are always kites. Well, not necessarily. It could be a trapezoid. They are never kites. Well, that's not true either, because sometimes we can have a kite. So that's why quadrilaterals are sometimes kites. Every trapezoid is an isosceles trapezoid. This is never true because of that word every. Every trapezoid is not going to be an isosceles trapezoid. I can have a trapezoid that does not have congruent legs. It only has congruent or parallel bases. And because of that, that word every means that this has to be never.